Since ancient times, humanity has gazed at the stars with a mixture of wonder and curiosity. The desire to understand what lies beyond our Earth has led to centuries of exploration and discoveries. One of the most fascinating of these discoveries is the existence of exoplanets, worlds that orbit stars outside our solar system. These planets, often with strange and unimaginable characteristics, have expanded our understanding of the cosmos and forever changed the way we see our place in the universe. When we look up at the night sky, we see stars that, until recently, we believed were solitary, like our sun. However, we now know that most of these stars host their own planetary systems. In our solar system, we have 8 planets orbiting the sun, with the 4 innermost being rocky and the 4 outermost being gas giants. This pattern, however, is not a universal rule. The exoplanets discovered to date challenge our traditional notions of planetary formation and composition. The first confirmed discovery of an exoplanet occurred in 1992, and since then, over 5,000 exoplanets have been identified. This initial discovery marked the beginning of a new era in astronomy, where the focus was no longer solely on stars, but on the worlds that orbit them. The diversity of these exoplanets is impressive. Some are gas giants like Jupiter, while others are rocky worlds that could resemble Earth. However, the similarities often end there. Many of these exoplanets exhibit conditions that defy imagination. For instance, some have atmospheres so hot that iron is vaporized and falls as liquid rain. Others have orbits so elliptical that they experience extreme climates, with temperatures varying dramatically from one side of the planet to the other. There are even exoplanets that have been ejected from their star systems and now drift through interstellar space as solitary worlds. A notable example is the exoplanet HD 1897333b, a gas giant located about 63 light-years from Earth. This planet, though a vibrant blue color similar to our own, is no aquatic paradise. In fact, HD 1897333b is a hellish world where it rains glass. The wind on this planet blows at speeds of up to 9,000 kilometers per hour, causing shards of glass to be hurled through the atmosphere at supersonic speeds. Imagine a world where the sky, instead of offering the comfort of rain, becomes a deadly storm of glass fragments. This is just one example of the extreme conditions found on exoplanets, often surpassing even the wildest conceptions of science fiction. Another fascinating exoplanet is Kepler-10b, one of the first rocky planets discovered outside our solar system. Kepler-10b is so close to its parent star that its surface is in a constant state of fusion, with temperatures reaching up to 1,300 degrees Celsius. This world, which could be seen as a hellish version of Earth, gives us an idea of how varied the habitability of rocky planets can be. While it is unlikely that life as we know it could exist in such an inhospitable place, the mere existence of Kepler-10b makes us reconsider what we consider to be a habitable planet. But it's not just the planets close to their stars that are intriguing. There are also those that orbit so far away that they receive almost no heat from their parent stars. These exoplanets are icy worlds, where temperatures drop to extremely low levels, and the possibility of life, if it exists, would be very different from anything we know. Instead of relying on sunlight, forms of life on these hypothetical planets could harness the heat generated by geothermal processes or even the natural radioactivity of the planet. The methods used to discover these exoplanets are as varied as the planets themselves. The transit technique, for example, observes the dimming of a star's light as a planet passes in front of it. This technique allows us not only to identify the presence of a planet, but also to estimate its size, atmospheric composition, and even the presence of rings and moons. Another common method is radial velocity, which detects the wobble of a star caused by the gravitational pull of an orbiting planet. These methods, along with more advanced ones such as gravitational microlensing and astrometry, have allowed astronomers to discover planets in increasingly distant locations and under increasingly varied circumstances. Technological advancements, such as the launch of dedicated space telescopes, have been crucial to progress in this area. The Kepler Space Telescope, for example, was responsible for the discovery of thousands of exoplanets, significantly expanding our catalog and understanding of planetary diversity. Future missions, such as the James Webb Space Telescope, promise to reveal even more details about these distant worlds, allowing scientists to study their atmospheres and search for signs of life. The search for habitable exoplanets is undoubtedly one of the greatest endeavors of modern astronomy. The idea that life could exist on other planets has always fascinated humanity, and the discovery of exoplanets in habitable zones, regions around stars where liquid water can exist, has intensified the search. Although we have not yet found conclusive evidence of life beyond Earth, the possibility that it exists somewhere in the universe is an idea that continues to inspire scientists and the general public alike.
However, the discovery of exoplanets is not just a scientific matter. It also has profound philosophical and cultural implications. The idea that we are not alone in the universe, that there are other worlds with the potential to harbor life, challenges traditional notions of our uniqueness. Moreover, the discovery of exoplanets expands our understanding of how life can evolve in different environments, suggesting that the universe may be far richer and more diverse than we ever imagined. The cultural impact of exoplanet discoveries is evident in literature, cinema, and art. Many of the concepts explored in science fiction, such as alien worlds and extraterrestrial civilizations, now have a basis in scientific reality. Films and books that were once considered pure fantasy now seem prophetic as scientists continue to find worlds that challenge our understanding. The idea of colonizing exoplanets, which was once the exclusive domain of science fiction, is now a serious consideration for the future of humanity. The exploration and potential colonization of exoplanets would not only be a monumental technical feat, but would also raise complex ethical and philosophical questions. How should we treat worlds that do not belong to us? What rights, if any, would the life forms we encounter have? These are questions that scientists, philosophers, and the general public will have to confront in the coming years. Finally, the future of exoplanet research is promising. With new missions planned and technologies in development, we are only beginning to scratch the surface of what we can discover. The James Webb Space Telescope, for example, will be able to analyze the atmospheres of exoplanets in unprecedented detail, searching for signs of biosignatures, chemical compounds that could indicate the presence of life. Additionally, missions like the Transiting Exoplanet Survey Satellite, TESS, will continue to expand our catalog of exoplanets, discovering increasingly smaller and more Earth-like worlds. In summary, the discovery of exoplanets has opened a new frontier in space exploration and our understanding of the universe. Each new planet discovered gives us a glimpse of a world that, as strange as it may be, helps us better understand the cosmos and our place in it. The study of exoplanets is not just a scientific journey. It is an exploration of the very essence of what it means to be human in a vast and unknown universe.